Hello everybody. So today we're going to be doing geometric series. So we're going to go straight into the proof. We're not going to waste any more time. We are just going to go straight into the proof. So just like the other one where we had Sn is equal to T1 plus T2 plus T whatever. So it's going to be dot 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 all the way until Tn minus 1 plus Tn as it is. So until the last term, right? Remember that in the last one, we had A as the first term, then A plus D as the second term, all the way to the last term, which is A plus N minus 1 into D. That was arithmetic series. But now we have geometric. And my question to you is, with geometric, what is it going to be? Because we clearly know that term 1 in geometric is just going to be A. But then term 2 is going to be A multiplied by R. And then term 3 is just going to be equal to A times R squared. Okay. And then from here, we are going to go all the way to Tn minus 1, which is essentially just going to be what? A R to the power of n minus 2. And then we're going to have Tn, which is just going to be AR to the n minus 1. Okay. So we're just going to substitute from here. Okay. So this implies that Sn is just going to be equal to A plus A times R plus dot 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 plus AR n minus 2 plus AR n minus 1. But this is going to be equation 1 for us. So we're going to take another equation, but in the case where we multiply both sides by r. So we are just going to do the following. We are going to multiply both sides by r, such that what we get is going to be r times Sn. And then it's just going to be what? AR, right, is where we're going to start. So it starts here, obviously, because when we multiply A by R, we get AR. But just look at the order. I'm just showing it like this. Plus dot 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 all the way to, what is A times R to the n minus 2 multiplied by R? Well, essentially we're just adding by 1 in that case. And therefore that's just going to be A times R to the power of n minus 1 plus A times R to the power of n. Okay. And we'll call this equation 2. And then what we're going to do, there's two methods that we are going to approach this from. Number 1. Okay, let me not rather do that. So, let's do this. Okay. We are going to subtract one from 2. So essentially that is just saying 2 minus 1. Okay, we're subtracting 1 from 2. So in that case, what it's going to look like is 2 minus 1 is the same as saying R times S sub n minus S sub n, which is just number 1, is the same as saying what? We are taking all of this. Remember that these are going to cancel, these are going to cancel, or whatever was before then, and these are going to cancel, and then what we are left with is just A times R to the power of n minus A. Okay. So that is that case. So therefore, we are left with AR to the power of n minus A. Okay. And then from here, all we are going to do is take out Sn as a common factor, because on the left hand side we can see that Sn is a common factor. So then we have R minus 1 into the remaining factors. And then this is equal to, we can take out A as a common factor, and then we have R to the power of n minus 1. And then what we'll do, we need to solve for Sn. So we'll divide both sides by R minus 1, and therefore we're left with A into r to the power of n minus 1 over r minus 1. Okay, and there's our first equation. And when do we use this? We use this when we use this equation when r is greater than 1. So whenever we have a ratio that is greater than 1, a constant ratio that's greater than 1, then therefore we will use the first equation. But what if the case happens when we subtract? So subtract 2 from 1. Then in that case we are taking 1 and we're subtracting it by 2. This is the other case. Okay? So this just indicates we are going to take Sn, which is equation 1, and minus it by Rsn. Okay? And this is going to be the same as what? So let's say 1 minus 2, then what are we cancelling? Well, clearly, we're going to cancel the ARs, we're going to cancel these over here, and whatever was before that. And then all we left with is A minus A times R to the power of N. Okay. So I said A minus A times R to the power of N. And then we take our common factors again, like we just did the other one. So Sn can come as a common factor, and it'll be 1 minus R left over. And then we take out A as a common factor, and we're left with 1 minus R to the N as a common factor. And therefore, if we divide both sides by 1 minus R, we have A into 1 minus R to the power of N divided by what? 1 minus R. And when do we use this equation? Because now we just solve for Sn for the other way. We use this when our R is less than 1. Okay. So our R can never be equal to 1 because clearly it's going to be a denominator that is 0. So therefore we say strictly either greater than 1 or strictly less than 1. Okay. So now let's actually use these formula that we have into proper examples to better understand what to do. Okay, so this will be the only example that I'll be doing in this one because basically it's just about knowing the formula at this point. And then just like in the arithmetic, you'll use the same logic just as what we did with arithmetic. Basically we'll do here because it's just series, right? But with different formula. So in this case, we have 1 plus 3 plus 9 all the way to 8 terms. So what are we trying to find? So we need to use S8. But we need to first figure out which formula to use. Well, because our ratio, how do we find our ratio? In order to find our ratio, instead of saying T2 minus T1 and whatnot, we will say T2 divided by T1 is equal to T3 divided by T2. So instead of saying minus, it's now divided by. So what is T2? T2 is just 3 divided by T1, which is 1, equals to T3, which is just 9 over 3, which is T2. And notice that 3 over 1 is 3, and 9 over 3 is just 3. Okay. So this just indicates that this is a geometric. And now R is just represented by the 3. So therefore, because R is greater than 1, then therefore we are going to use the formula which has R first. So A into R to the power of N minus 1 over R minus 1. So let me rather keep it as Sn equals that. So we'll use this Y because in our case R is greater than 1. Okay. So then this implies to us here that we want to find S to 8 terms. So what do we know about A? A is the first term, and we know that A is just 1. So therefore we have 1 multiplied by R, which is, what is R equal to? It's 3 raised to the power of N, which is 8 minus 1. And this is all divided by what? R, which is 3 minus 1. And what is the value of all of this? Well, according to what I have, it's 3,280. And intuitively, you should understand how to answer every other question if you look back at arithmetic sequences in that case. And then if you get a question where the r is maybe a fraction, for example, maybe if r was equal to a half, you would clearly use the formula that was the other way around, where 1 starts and then it will be 1 minus r in the denominator, if that makes sense. So if we have like some rational value, such as below 1, so between 0 and 1, then therefore we would use the other formula instead. But in this case, it's greater than 1, we use this formula over here.